narrative is about a third-generation electrician with over 30 years of experience and a master electrician certification, expressing frustration with the lack of electrical safety and licensing in his small town. This electrician was asked to work on an over a century-old historic building that has an outdated and potentially hazardous electrical system. The electrician identifies open service conductors, abandoned disconnects, and a lack of proper equipment grounding. Then the electrician meets with the building inspector, who approves the use of conduit but doesn't require safety measures such as proper grounding. The electrician also encounters resistance from a carpenter who wants to wire offices using Romex and connect to the electrician's work, which the electrician objects to due to safety concerns. The lodge's caretakers refuse to cooperate with the electrician's concerns and instead hire a licensed electrician who is the caretaker's son. The electrician believes the work is still incomplete and unsafe. The electrician is saddened that the lodge has ignored the concerns despite the historic value of the building. The narrative laments the lack of electrical regulation and standards in the town, where unqualified individuals are allowed to perform electrical work without proper training or licensing. The electrician has witnessed dangerous and unsafe practices, such as switching neutrals and using green as a circuit conductor. The electrician takes pride in electrical skills and believes the work should be held to a high standard. The electrician is frustrated that unqualified individuals are allowed to perform electrical work, compromising public safety. The electrician considers attending a city council meeting to address the issue but realizes that it may not make a difference. In conclusion, the electrician expresses frustration with the lack of electrical safety and regulation in the small town. The electrician believes that unqualified individuals should not be allowed to perform electrical work and that public safety should be a priority. There are many electrical code rules. Firstly, the National Electrical Code, or NEC, is a comprehensive set of guidelines and standards for electrical installations in the United States. It's updated every 3 years to reflect the latest advancements and safety practices. Secondly, grounding and bonding are crucial for safety. Grounding provides a path for fault current to return to the source, tripping a breaker or fuse and preventing electrical shock. Bonding ensures that all metal parts are at the same potential, minimizing the risk of shock. Thirdly, overcurrent protection devices like circuit breakers and fuses are designed to protect electrical circuits from excessive current, which can cause overheating and fires. They must be sized appropriately for the circuit they protect. Fourthly, conductors must be sized according to the ampacity, which is the maximum current they can safely carry. Factors like insulation type, ambient temperature, and the number of conductors in a raceway affect ampacity. The NEC has tables that provide guidance on conductor sizing. Fifthly, wiring methods refer to how conductors are installed and protected. Common methods include conduit, such as electrical metallic tubing, or IMT, and non-metallic sheath cable, often called Romex. Each method has specific requirements for installation and support. Sixthly, boxes and enclosures are used to protect electrical connections and devices. They must be sized appropriately for the number of conductors they contain and must be securely mounted. Seventhly, branch circuits are the circuits that extend from the panel board to the outlets and fixtures. They must be wired according to the NEC and must have the correct overcurrent protection. Eighthly, lighting and appliance requirements cover the installation and wiring of lighting fixtures and appliances. The NEC specifies requirements for things like clearances, support, and grounding. Ninthly, special occupancies like hazardous locations, healthcare facilities, and places of assembly have additional requirements due to the increased risk of electrical hazard. Tenthly, inspections are an important part of ensuring electrical safety. Electrical installations are typically inspected by local authorities to verify compliance with the NEC and other applicable codes. Some common electrical code violations include overloaded circuits. This happens when too many devices are plugged into a single circuit, exceeding its ampacity and potentially causing a fire. Another is improper grounding and bonding. This can create a shock hazard and prevent overcurrent protection devices from operating properly. Another violation is using the wrong type of wiring for the application, such as using Romex in a wet location, which is a safety hazard. Next, exposed or damaged wiring is also an electrical code violation. Wiring that is not properly protected or that has been damaged can create a shock or fire hazard. Another violation is missing or improperly installed junction boxes. Junction boxes are required to protect electrical connections and prevent them from becoming a safety hazard. Another common violation is blocked access to electrical panels. Electrical panels must be easily accessible in case of an emergency. Another is using the wrong size of overcurrent protection, such as using a 30-amp breaker on a 15-amp circuit. This can prevent the breaker from tripping in the event of an overload, increasing the risk of fire. Next, not following manufacturer's instructions is also an electrical code violation. Electrical equipment must be installed and used according to the manufacturer's instructions to ensure safe operation. Some common electrical hazards include electric shock. This can occur when a person comes into contact with a live electrical conductor. The severity of the shock depends on the voltage, current, and duration of contact. Another hazard is electrical fires, which can be caused by overloaded circuits, short circuits, or faulty wiring. Electrical fires can spread quickly and are difficult to extinguish. Another electrical hazard is arc flash, which is a dangerous electrical explosion that can occur when there is a fault in an electrical system. Arc flash can cause severe burns and other injuries. Another hazard is electrocution, which is death caused by electric shock. Electrocution can occur when a person comes into contact with a high-voltage electrical conductor. Some safety tips for electrical work include always energizing circuits before working on them. This is the most important safety precaution to prevent electric shock. Also, use properly insulated tools. Tools with insulated handles can help to protect you from electric shock. Another safety tip is to wear appropriate personal protective equipment such as safety glasses and gloves. Another tip is to follow the NEC and other applicable codes. The NEC provides guidelines for safe electrical installations. Another safety tip is to hire a qualified electrician for electrical work that you are not comfortable doing yourself. A qualified electrician has the training and experience to perform electrical work safely. To further elaborate on the NEC, it is not just a set of rules, it's a comprehensive document that outlines the minimum safety requirements for electrical installations. Think of it as a living document constantly evolving to address new technologies and emerging hazards. Let's dive deeper into some key areas. Grounding and bonding are the cornerstones of electrical safety. Grounding provides a low impedance path for fault current to flow back to the source, allowing overcurrent protection devices to quickly trip and clear the fault. Bonding ensures that all metal parts of an electrical system are at the same electrical potential, minimizing the risk of shock. Overcurrent protection devices, like circuit breakers and fuses, are the guardians of electrical circuits. They are designed to interrupt the flow of current when it exceeds a safe level, preventing overheating and potential fires. Selecting the right size of overcurrent protection is critical. Too small, and it will nuisance trip. Too large, and it won't protect the circuit. Conductors, the pathways for electrical current, must be sized appropriately for the load they will carry. The NEC provides tables that take into account factors like ampacity, insulation type, and ambient temperature to ensure conductors can operate safely without overheating. Wiring methods dictate how conductors are installed and protected. Conduit, such as ENT and rigid metal conduit, provides a robust mechanical protection, while cable assemblies like Romex offer flexibility for certain applications. Each wiring method has specific requirements for support, protection, and installation. Boxes and enclosures are the containers that house electrical connections and devices. They provide protection from physical damage and environmental factors. The NEC specifies minimum box sizes based on the number and size of conductors they contain. Branch circuits are the final circuits that supply power to outlets, lighting, and appliances. The NEC regulates the number of outlets allowed on a circuit and specifies the type of wiring and overcurrent protection required. Lighting and appliance installations must comply with specific requirements to ensure safety and efficiency. These requirements cover aspects like clearances, support, grounding, and energy efficiency. Special occupancies, such as healthcare facilities, hazardous locations, and places of assembly, present unique electrical challenges. The NEC has specific requirements for these occupancies to address the increased risk of electrical hazards. Healthcare facilities, for example, require backup power systems and isolated power systems to protect patients. Hazardous locations, where flammable materials are present, require explosion-proof wiring methods and equipment. The electrical inspections are the final checkpoint to verify that an electrical installation complies with the NEC and other applicable codes. Inspections are typically conducted by local authorities and are an essential part of ensuring electrical safety. Let's talk more about those common code violations. Overloaded circuits are a frequent culprit, often resulting from plugging too many devices into a single circuit. This can cause the circuit to overheat, potentially leading to a fire. Improper grounding and bonding is another common violation, which can create a shock hazard and prevent overcurrent protection devices from operating correctly. Using the wrong type of wiring for the application can also lead to problems. For example, using Romix in a wet location can create a shock hazard and cause the wiring to deteriorate. Exposed or damaged wiring poses a significant safety risk. Wiring that is not properly protected or has been damaged can create a shock or fire hazard. Missing or improperly installed junction boxes are another common violation. Junction boxes are required to protect electrical connections and prevent them from becoming a safety hazard. Blocked access to electrical panels can hinder emergency response. Electrical panels must be easily accessible in case of a problem. Using the wrong size of overcurrent protection can also be an issue. For instance, using a 30 amp breaker on a 15 amp circuit can prevent the breaker from tripping in the event of an overload, increasing the risk of fire. Not following manufacturer's instructions can also be a problem. Electrical equipment must be installed and used according to the manufacturer's instructions to ensure safe operation. Electrical hazards are a serious concern. Electric shock can occur where a person comes into contact with a live electrical conductor. The severity of the shock depends on the voltage, current, and duration of contact. Electrical fires can be caused by overloaded circuits, short circuits, or faulty wiring. These fires can spread quickly and are difficult to extinguish. Arc flash is a dangerous electrical explosion that can occur when there is a fault in an electrical system. It can cause severe burns and other injuries. Electrocution is death caused by electric shock and can occur where a person comes into contact with a high voltage electrical conductor. To stay safe while performing electrical work, always de-energize circuits before working on them. This is the most important safety precaution to prevent electric shock. Use properly insulated tools. Tools with insulated handles can help protect you from electric shock. Wear appropriate personal protective equipment, such as safety glasses and gloves. Follow the NEC and other applicable codes. These codes provide guidelines for safe electrical installations. Hire a qualified electrician for electrical work that you are not comfortable doing yourself. A qualified electrician has the training and experience to perform electrical work safely. Think of the electrician as a detective, who's not only trained, but also understands how electricity works and how to implement it safely. Electricians work on an old building with an outdated electrical system, or a modern smart home with the latest technology. They will ensure that your electrical system meets the current standards. An electrician will diagnose electrical problems. Whether it's a flickering light, a tripping circuit breaker, or a complete power outage, a qualified electrician can troubleshoot the problem and identify the cause. They have the tools and knowledge to safely diagnose electrical issues and recommend the appropriate repairs. Electricians perform electrical installations. They can install new wiring, outlets, lighting fixtures, and electrical panels. They ensure that all installations are performed in accordance with the NEC and local codes. Electricians perform electrical repairs. From replacing damaged wiring to repairing faulty outlets and switches, electricians can handle a wide range of electrical repairs. They use their expertise to restore electrical systems to safe and reliable working conditions. Electricians perform electrical maintenance. Regular electrical maintenance can help prevent problems and extend the life of your electrical system. Electricians can inspect your wiring, test your outlets, and identify potential hazards. Electricians upgrade electrical systems. As technology advances and your electrical needs change, electricians can upgrade your electrical system to meet the demands of modern life. They can install new electrical panels, run new circuits, and upgrade your lighting. Electricians ensure electrical safety. The primary goal of an electrician is to ensure the safety of your electrical system. They follow strict safety protocols and use their knowledge to minimize the risk of electrical shock, fire, and other hazards. Electricians must have extensive training and education. Electricians undergo a rigorous apprenticeship program that combines classroom instruction with on-the-job training. This program teaches them the fundamentals of electricity, wiring methods, and safety procedures. Electricians must be licensed and certified. Licensing and certification ensure that electricians have met certain minimum standards of knowledge and experience. Licensed electricians are required to stay up to date on the latest codes and regulations. Electricians must have specialized skills and knowledge. Electricians must be proficient in reading blueprints, using electrical testing equipment, and troubleshooting electrical problems. They also need to be familiar with the NEC and local codes. Electricians must have experience in a variety of electrical applications. Electricians work on a wide range of electrical systems, from residential wiring to industrial machinery. They must have experience in different types of electrical applications to be able to handle any job. Electricians must be committed to safety. Safety is the top priority for electricians. They follow strict safety protocols and use their knowledge to minimize the risk of electrical hazards. The electrician is a critical member of our communities. They are dedicated to ensuring the safety and reliability of our electrical systems. So, the next time you need electrical work, be sure to hire a qualified and licensed electrician. It's an investment in your safety and peace of mind.